In this video, we're going to learn some of the basic derivative rules that will allow us to skip using the limit definition and get the derivative much faster using these alternative methods. So the first rule is the power rule. It says the derivative of any time you have x to a number is just going to be that number times x to one smaller number. So we did a derivative of x squared once upon a time, and we did a whole limit, a bunch of extra work here. Now this says the derivative is just going to be 2 times x to the 1, because 1 is smaller than 2. If I had x to the 5th and I wanted the derivative, it would be 5x to the 4th. This also works for things like the square root of x, because you can write the square root of x as x to the 1/2 power, and we'd get 1/2 x to the negative 1/2. This also works for things like 1 over x, because 1 over x is the same as negative 1, and we get negative 1x to the negative 2. So just this right here, this power rule, it's a rule that you're going to use so often, over and over again, and it's going to save you so much time compared to using limits from before. So that's the first rule. The next two rules, the sum and difference rule, is just saying that if, for example, you are adding two things together and take the derivative, that you are allowed to find the derivative of each thing separately and add the two answers. Similarly, you could do the same thing for subtracting. You could go ahead and take the derivative of each part separately and subtract the two answers. Notice that I was subtracting there, but the derivative of 1 over x had an extra negative sign there, so that turned it into a plus. So just keep that in mind where the plus came from. The next is the constant rule. This is the easiest rule to deal with. It says if you have the derivative of just a number by itself, it's going to be 0. I do want to point out, though, this is different than the constant multiple rule, whereas if you have a number in front of an x, it is not going to be just 0. Instead, you just bring that number along for the ride and take the derivative of the other part. The x squared goes to 2x, and then the final answer here would be 10x. Okay? And then the last of these beginning rules is the exponential rule. It says the derivative of a function e to the x is just to itself. I mean, the example is just that. There really isn't anything else. You could have a number in front, 3e to the x, and the number comes along for the ride. So in fact, e to the x is simply the best function in calculus. You don't have to do like anything with it. It's great, but this is what we have. So these are the first rules here, and hopefully you see how much time you're going to save by implementing these rules. And then in future videos, we're going to see more rules, including some of the ones that are a little bit harder, but they still would save a lot of time over using the limit definition.